Dear students, in this video, I am going to discuss or going to start dynamic programming problem. So what is the dynamic programming problem? So definition is dynamic programming is a mathematical technique dealing with the optimization of multi-stage decision process. So here we are dividing the problem into multi-stages. Fine. We will discuss how we will construct the problem into stages. We will discuss this in later on, but we will divide the problem into stages. The word programming has been used in the mathematical sense of selecting an optimum allocation of resources, and it is dynamic as it is particularly useful for problems where decisions are taken at several distinct stages. So this process is basically a dynamic procedure. Fine. Richard Bellman developed this technique in early 1950s and invented its name. So here basically we have a problem, suppose with n variables. Then if we apply the dynamic programming, then generally we will divide the problem into n sub problems. Here n variables, here n sub problems. So we will basically break the problem into n problems. Here each problem is a single variable problem. तो हम n वेरिएबल की प्रॉब्लम को n प्रॉब्लम्स में डिवाइड कर लेंगे और हर प्रॉब्लम सिंगल वेरिएबल की प्रॉब्लम होगी. This procedure is basically a dynamic procedure. Fine. That's why the name of the programming is dynamic programming. So what is the Bellman? Here we have used the term Bellman. So what is the Bellman principle of optimality? Because the dynamic programming is based on this principle. What is the principle? An optimum policy. Here set of decisions. In this policy we have to take the or extract some set of decisions. Has the property that whatever be the initial state and initial decisions, the remaining decisions must constitute an optimum policy for the state resulting from the first decision. यानी कि आपकी कोई भी इनिशियली आपने कोई भी डिसीजन लिया हो, उसके बाद आने वाले जो डिसीजंस हैं वो जब आप उनको कंस्टिट्यूट करते हो तो यू कैन फाइंड एन ऑप्टिमम पॉलिसी. आप ऑप्टिमम पॉलिसी बना सकते हो. आप कुछ भी डिसीजन लिया हो आपने स्टार्टिंग में, बट अल्टीमेटली यू कैन रीच टू एन ऑप्टिमम पॉलिसी or you can design an optimum policy. ठीक. So this is the procedure. So note, a problem which does not satisfy the principle of optimality cannot be solved by dynamic programming. तो जो भी प्रोग्रामिंग प्रॉब्लम इस प्रिंसिपल को होल्ड नहीं करती, उसको हम इससे सॉल्व नहीं कर सकते डायनेमिक प्रोग्रामिंग से. नो मैथमेटिकली और ग्राफिकली हियर इज द प्रोसीजर. हियर इनिशियली सपोज वी हैव system or problem in state. State means a state is denoted by symbol Sn. Here the problem is in state Sn. At this state we have to take some decision and those decisions are denoted by dn. Finally these are the state variable, this is the decision variable, and they will constitute a return function. After this we have whatever be the decision, whatever be the state, you have some return function denoted by fn, dn, sn. And this state is denoted by the state function, which is, or the we can say that this state function tn depends upon this decision and state, this state sn, and then we have a return function. Now whatever we have extracted from here, whatever be the decision we have extracted here, that decision is passed to the next state. That's why Sn minus 1 is the state, next state, in decreasing manner. Here we have to take a decision dn minus 1. Again this Sn minus 1, this dn minus 1 constitute a return function denoted by this fn minus 1, dn minus 1, Sn minus 1. Again this state is denoted by state n minus 1, and the function will be tn minus 1, depends upon this and this. So tn minus 1, sn minus 1. Again this decision is send it to the next state, sn minus 2, and so on. This is the second last stage, which is the first state. First state, stage 1. Here we have decision variable 1. Here we have s1, s1, d1, and we get t1, d1, s1, and the return function is f1, d1, s1. And then finally we will send it to the initial state, d0, s0. This is the initial state, and this is the output or the return function, f0, d0, s0. So this is the procedure. Fine. So our objective is to maximize the sum of the return functions. Our aim is to maximize this return functions. This जो भी कुछ रिटर्न मिल रहा है हर स्टेट से, इसको मैक्सिमाइज करना हमारा एम है, अगर हमारी प्रॉब्लम मैक्सिमाइजेशन की है, और मिनिमाइजेशन if the problem is related to, for example, say cost. So our problem is to maximize the sum of the return functions or minimize the cost functions over all the stages of the decision process. Our only constraints on this optimization are that the decision chosen for each state belong to the some set dn of the permissible. That means whatever we are decision taking, they should belong to some set. They should not expect it to beyond our limits. Fine. They should be relevant and belongs to a set of decisions. यानी हम जो set of decisions हम ले रहे हैं उसी के अंदर वो belong होना चाहिए. ऐसा ना हो कि decision उस set से बाहर आ जाए, ठीक, उससे बाहर नहीं होना चाहिए. So this is the meaning. So decisions and the transition function state to state be governed by the equation this. So what if you will see here, whatever you have extracted here, this is the state function or transition function. This is send it to the next stage, which is denoted by sn minus 1. So they should be same. They should be same. And hence we are saying sn minus 1 is equals to tn dn sn. Fine. That is the transition function such that given sn, this sn, the state of the process with n stages to go, the subsequent state of the process with n minus 1 stages to go is given by sn minus 1. ये हमें already पता था. is given sn, the state of the process with n stages to go. इसका मतलब है कि हमें n stages में भी जाना है, और जो subsequent state आने वाली है n minus 1, that is totally depends upon this previous state. Fine. So there is a connection between these two states. Now given that we are in state sn with n stages to go, our optimum problem is to choose the decision variables dn, dn minus 1, d0. So our aim is to find out these decisions to solve the following problem. Problem is basically our aim is to maximize this return function, total return function. So just take the sum of these and then find out the maximum of that. So that's why this is the maximum of fn dn sn, fn minus 1 dn minus 1 sn, and so on, and last is f0 d0 s0. And aim is to maximize this. Whatever we will get, that will basically reflected in the nth state, because our problem is a n variable problem. That's why v and sn subjected to the constraint कि जो भी हम डिसीजन ले रहे हैं वो हमारे set of decision variables में आना चाहिए. So di should belong to some di. This is the set of decision variable related to the ith variable. This is its universal set actually for the ith variable. So जो भी आप ith variable ले रहे हैं di, वो इस set of universal set जो कि di i वेरिएबल के लिए है, क्योंकि हर वेरिएबल का अपना एक सेट होगा. d1 के लिए अपना होगा, d2 के लिए अपना होगा, dn के लिए अपना होगा. सो di ith वेरिएबल के लिए जो सेट है वो di है. फाइन. एंड हियर sm minus 1 is equal to tm dm sm, where m is 1 to n and here I is 0 1 to n. So this is the problem. We call V and Sn the optimum value function. So this is basically the optimum value function. Now one can be written as, अब हम इसको क्या कर सकते हैं, इसको दो हिस्सों में ब्रेक कर सकते हैं. One part is this and another part is this, so that we can have a recurrence relation. So that's why we have taken this part separately and this part separately. So here is maximum, here is maximum. Here this function depends upon dn Sn, and hence Sn minus 1 is equals to Tn dn Sn. This is, and here dn belongs to dn. But here we are having from 0 to n minus 1. So Sm minus 1 as it is same, Sm minus 1 Tm dm Sm, dm belongs to dm, where m belongs to here 1 to n minus 1, and here the m belongs to 0, 1 to n minus 1. Fine. So this is the procedure. So now V and Sn can be written. What is this? This is maximum of Fn dn Sn plus, what is this? This is nothing but, if you will compare this with this definition, here is n minus 1, here is n. So if here is n, then we are using n, but here n minus 1, so that's why this can be replaced by Vn minus 1 Sn minus 1. So now we have a recurrence relation. If Vn minus 1 is given to you, then you can easily find out. For example, V naught is given to you, then you can find out V1. When you V1 you will put here, then immediately you can find V2 and so on. So you can find out basically a recurrence relation subjected to Sn minus 1 is equal to Tn dn Sn, and dn belongs to dn. So this is the recurrence relation. ठीक? So now here purpose is to solve this problem. Vn Sn is equal to maximum of Fn dn Sn plus Vn minus 1 Tn. What is Sn minus 1? Sn minus 1 is from here. From here, Sn minus 1 is nothing but Tn dn Sn, and dn belongs to dn. So this is the problem. Now we want to solve this problem. Fine. So here we have a solution procedure, how to solve this type of problems. So solution of a multi-stage problem by dynamic. DP means dynamic programming with finite number of stages. So we have a procedure. Procedure is, number 1, develop a recurrence relation connecting the optimum decision functions for n stage problem with optimum decision functions for the n minus 1 stage sub problems, where m is 1, 2 and n. That means first you have to construct this type of problem, stages problem. Then second task is solve the functional equations for determining the optimum policy. तो पहले हमें ये recurrence relation बनाना है for stages, and then we have to solve the functional equations in second part. Fine. So this is the procedure. For this, first we write the optimum decision functions for one state sub problem and solve it. यानी एक प्रॉब्लम के लिए हम बनाएंगे, उस एक स्टेट के लिए प्रॉब्लम उसको सॉल्व करेंगे, देन जो भी आपका आएगा उसको सेकंड स्टेज में पास करेंगे, थर्ड में पास करेंगे, फिर n-1 स्टेजेस में पास करेंगे, एंड अल्टीमेटली कलेक्ट ऑल दोज एंड गेट द सॉल्यूशन. दिस इज द स्ट्रेटेजी. ठीक. सो लेट्स सी एन एग्जाम्पल. तो एग्जाम्पल से आपको बहुत अच्छा समझ में आएगा. लेट्स सी द एग्जाम्पल. What is the basic idea? So suppose we want to find out the first example is related to the shortest route problem, and here we have selected the discrete problem. This is the discrete problem. This is not the continuous problem. इसलिए इसमें derivatives involved नहीं होंगे. Here if you will see, we want to find out the maximum. तो कैलकुलस में मैक्सिमम मिनिमा के लिए डेरिवेटिव भी यूज करते हैं सिंगल वेरिएबल प्रॉब्लम में, बट हियर वी आर हैविंग अ डिस्क्रीट प्रॉब्लम, सो देयर इज नो डेरिवेटिव इन्वॉल्व्ड. तो इसमें डेरिवेटिव इन्वॉल्व नहीं होंगे. ठीक. नाउ व्हाट इज द प्रॉब्लम? सेलेक्ट द शॉर्टेस्ट हाईवे रूट बिटवीन टू सिटीज. यानी दो सिटी के बीच में एक हाईवे है या एक से ज़्यादा हाईवे हैं, तो आपको शॉर्टेस्ट पाथ को सेलेक्ट करना है. The network in the figure provides the possible routes between the starting city at node 1 and the destination city at node number 7 here. So this is the starting city, this is the ending or destination city. And this is the route. You can move from 1 to 7 in number of ways, either here, here, here. Either you can move here, here, and then here. Either you can move here, here, and here. Either you can move here to here and here. So these are the all possible routes. What is your purpose? Purpose is to find out the shortest route from 1 to 7. यानी 1 से 7 के बीच का shortest path निकालना है. The routes passes through intermediate cities designated by nodes 2 to 6. So these are the intermediate cities. ये बीच में पड़ने वाले शहर हैं. Now this 7 basically the distance from 1 to 2, city 1 to city 2. This distance is 7. 7 may be kilometers, maybe any other unit. Similarly, from 1 to 3, the distance is 8. From 1 to 4, the distance is 5. Now, from here, for example, if you will see, from 2 to 6, there is no route. That's why there is no straight line joining 2 and 6. यानी 2 और 6 के बीच में कोई रूट नहीं है, इसीलिए कोई लाइन भी नहीं है. ठीक, क्लियरली. So between any two cities, if we have a line, then we can say that both these cities or nodes are connected to each other. Otherwise they are not connected. For example, 1 and 2 is connected, or 2 or 6 is not connected. However, 4 and 5 is connected because they are having a line. That's why. So now one can solve this problem by dynamic programming. So our interest is to find out this or to get the solution with the help of dynamic programming. Now first decompose it into stages as shown in the figure. This we have divided the problem into stages. Then either we can use forward recursion or backward recursion. Here we have two types of approaches. Either we can move from 1 to 7 or either we can move from 7 to 1. या तो हम 1 से 7 की तरफ मूव करें, दिस इज कॉल्ड द फॉरवर्ड रिकर्सन. एंड सेकंड इज इफ यू आर मूविंग फ्रॉम 7 to 1, देन दिस इज कॉल्ड द बैकवर्ड रिकर्सन. सेकंड अप्रोच इज बैकवर्ड रिकर्सन. ठीक, तो हम 1 से 7 की तरफ भी जा सकते हैं, हम 7 से 1 की तरफ भी जा सकते हैं. वी आर गेटिंग द सेम सॉल्यूशन. So we will discuss both these approaches. So first we will divide the network into stages. So this from here to here, this is first stage, here to here. From here to here we are having second stage, and from here to here we are having third stage. So ultimately we have divided the problem into 3 stages. तो 3 stages में हमने इसको divide कर दिया. This is the first stage, this is the second stage, this is the third stage. ठीक. Now here at each stage we are having start and end. For example, first stage, this is the start and this is the end. Similarly, in the second stage we are having start and this end, and in the third stage this is the start and this is the end. So in first stage, start is denoted by F1 and end is denoted by F2. Similarly, in the second stage, दिस इज द F2 एज इट इज सेम, क्योंकि यहीं से बाइफरकेट किया है, ये एज इट इज सेम है. सो दिस इज F2 एंड दिस इज डिनोटेड बाय F3. नाउ इन द थर्ड स्टेज, सिंस दिस इज F3, सो दैट्स वाई दिस इज F3 एंड लास्ट नोड इज डिनोटेड बाय F4. सो F1, F2, F2, F3, F3, F4. ठीक, तो हमने इसको F1 को डिनोट किया है, ये जो भी हमारा यहाँ पर होगा वैल्यू उसको F1 से डिनोट करेंगे. यहाँ पर जो भी वैल्यूज़ हैं उनको हम F2 से डिनोट करेंगे. जो भी यहाँ पर वैल्यूज़ हैं उनको हम F2 से डिनोट कर रहे हैं, क्योंकि ये एज इट इज़ सेम है, यही है एज इट इज़. तो F2, F2, ये F3, ये F3, ये F4. ठीक, अब ये आगे इसका प्रोसीजर कैसे है, वी विल डिस्कस इट लेटर ऑन इन द नेक्स्ट पेज. हियर नाउ स्टेज 1. So here we will write this network, otherwise we will have a problem. तो इसको एक सेपरेट पेज पे हम बना लेते हैं. Here we can construct this. Here we have 1, this is 7, this is 8, this is 5. Then here is we have 5, this is 6, this is 12, this is 8, this is 9, this is 7, this is 13. And then we have node number 7, 9 and 6. Fine. So this is our diagram. This is our diagram. Let's see. So here we have F1, here we have F2, here we have F3, here we have F4. Here we have F1, F2, F3, F4. Fine. So now stage 1. So here we are discussing, let's see, forward recursion. Forward recursion we are discussing. So what is the forward recursion? So start with this stage. Start with this. So here we have assumed that क्योंकि हम यहाँ से start कर रहे हैं, so we designate this as 0. So we designate this as 0. तो हम इसको 0 से designate करेंगे क्योंकि हम यहाँ से start कर रहे हैं. ठीक. So this is also 0. So this is 0. ठीक. Now stage 1. We are discussing this stage 1. This is stage 1 from here to here. Stage 1. This is from here to here stage 2. And from here to here stage 3. ठीक. Now this is 0. Now stage 1. Stage 1 means we are discussing this. So the shortest distance from node 1 to node 2 is 7. From here to here, what is the shortest distance? We have only one path and 7 is the distance. And hence we can write here in box 7. Now from here to here, we have only single path and the shortest distance is 8. And so write down here 8. So this is written here. Now from here to here, shortest distance is 5 only. So write down here 5 in the box. Fine. So stage 1 is over. Now stage number 2. Stage number 2, if you will see from here to here, from 2 to 5, basically we are moving from here to here. So here we have only two options, 5 and 6. 5 तक पहुंचने के कितने रास्ते हैं? 5 पे पहुंचना है. Either we can move from 2 to 5, 3 to 5 or 4 to 5. That's why in stage 2 we have two end nodes, 5 and 6. 5 and 6. The node 5 can be reached from nodes 2, 3 and 4. You can move from here to here, you can move from here to here, you can move from here to here. Via routes 2, 5, 2, 5, 3, 5, 3, 5, 4, 5, 4, 5. This information together with the summary result in stage 1 determines the shortest cumulative distance to node 5. यानी 5 तक पहुंचने के लिए अगर आप 2 से आए होंगे तो 2 तक पहुंचने के लिए भी 7 यूनिट्स आपने चले होंगे यहाँ से यहाँ तक. So this is the cumulative, then 1, 2, 2 to 5. So this is the cumulative sum. Similarly, if you are moving from 3 to 5, then to reach 3, basically from 1, you have covered 8 units. So 1 to 3, 3 to 5. This is the cumulative sum. Similarly, from 4th, if you are moving from 4th, then the cumulative sum is 5 and then 7. Fine. So this is the cumulative sum and this is written here. So shortest distance to node 5. What is the shortest distance? To node 5 is minimum of here. Minimum of the shortest distance to node I, where I is 2, 3, 4. 2, 3 and 4. These are the three possible nodes. So they are 2, 3, 4. Plus the distance, once you reach at this point, then the distance between here to here. ठीक है ना? The distance from node I to 5. Here the distance I may be 2, I may be 3, may be 4. So here the minimum of, now the shortest distance to node I. Here I may be 2, 3 or 4. If you are taking 2, shortest distance is 7. 7. 7 plus this distance is 12. यानी यहाँ से यहाँ तक 7 डिस्टेंस लगा, फिर यहाँ से यहाँ तक 12 डिस्टेंस लगा. So this is 7 plus 12 is 19. Second, if you are moving from 3, so at 3 the minimum distance is 8, this 8, and from here to here again the distance is 8, so 8 plus 8, so 8 plus 8 is 16. If you are moving from 4, shortest distance is 5, and from here to here the distance is 7, so 5 plus 7, so this is 19, this is 16, this is 12. Now among these minimum is 12, and 12 means this point, so that means third option is 4. So from node 4, so this is basically you are moving from here to here and then from here to here. This is the minimum to reach 5. Similarly to reach 6, 6 तक आने के लिए हमारे पास दो ऑप्शन है, या तो मैं यहाँ से यहाँ हूँ या मैं यहाँ से यहाँ हूँ. 3 and 4, these are the possible values of I, and hence for node 6 we have minimum of 3 and 4. Now the shortest distance to node I plus the distance from node I to node 6, where I is either 3 or 4. So if you are selecting minimum from 3, then here the 8, and the distance from 3 to 6 is 9. So 8 plus 9 is 17. Now the distance from 4 to 6 is 5 plus 13. So 5 plus 13 is 18. ठीक, तो 6 तक आने के लिए हमारे पास केवल दो ही पाथ थे, या तो मैं यहाँ से आऊँ, मैं यहाँ से आऊँ. अगर मैं यहाँ से आता हूँ, सो हियर यहाँ तक 8 है, और 8 प्लस 9 हो जाएगा 17, और यहाँ पर 5 है, 5 प्लस 13 is 18. Now take the minimum is 17, which is associated with this 3, and hence 17 from node number 3. ठीक. Now stage number 3. So we have solved stage number 1, stage number 2. Now we are having final stage number 3. So in stage number 3, we have one end node 7. We have here only one node 7. So either we can reach 7 from 5 or from 6. Fine. So here the minimum is 6. 6 पर जो minimum है वो box बना देते हैं. Here is 17. So this is the 17, and here minimum is 12. So here is 12. ठीक, तो ये box आपको बनाना है. ठीक है. So now अब आपके पास दो ऑप्शन है यहाँ तक पहुँचने के, या तो यहाँ से जाएंगे या यहाँ से जाएंगे. If you are moving from 5 to 7, then up to 5 minimum distance is 12, then 12 plus 9, this will give you the distance. So here in stage 3 we have one end node 7, which can be reached from nodes 5 and 6 via routes 5, 7 and 6, 7. 5, 7 or 6, 7. ठीक. This information together with stage 2 result, we can find the shortest distance to node 7 as shortest distance to node 7 is the minimum of shortest distance to node I plus the distance from node I to 7. ठीक. So this is I is either 5 or 6. So I is either 5 or 6. So reach up to here and then from here to here. ठीक. So here if you are selecting 5, then the shortest distance up to 5 is 12. So 12, and then from 5 to 7 the distance is 9. So 12 plus 9. So 12 plus 9 is 21. If you are selecting this node, the shortest distance up to 6 is 17 units, and from 6 to 7 the shortest distance is 6. So 17 plus 6. So 17 plus 6 is 23. Now find out the minimum of these two. So 21. and 21 is extracted from here, that means from 5. So from node 5. So from node 5 we can move from here to here. So what is the shortest route? Shortest route is 1 to 4, 4 to 5 and 5 to 7. So 1 to 4, 4 to 5 and 5 to 7, and distance is 21. So here we have 21. 21 is the shortest distance. So this is the solution of the shortest path problem. If we are moving from here to here forward, now solve the same problem with backward recursion. So now we will solve the same problem with backward recursive equation. This is the method number 2. ठीक, अब हम इसको backward recursion से solve करेंगे. कैसे करेंगे? So now we will start again, construct the graph, again construct the same graph, or let's see, we will use this graph. We will use this graph. ठीक, so let's see here. So designate. ना अब हम यहाँ से स्टार्ट करेंगे और फिर बैकवर्ड ट्रेसिंग करेंगे इधर से इधर. ठीक, सो हम पहले हमने आपको याद है इसको 0 दिया था, अब हम इसको 0 देंगे. सो f4 x4 इज इक्वल टू 7 इज 0. व्हाट इज x4 इज इक्वल टू 7? दिस वैल्यू, दिस इज 7. ठीक, और इसको जो हमने वेरिएबल दिया है x1 x2 x3 x4. ठीक, जैसे हमने इसको f1 f2 f3 f4 दिया था, अब हम इसको वो दे रहे हैं. आप f भी दे सकते हो, नो प्रॉब्लम, बट वी आर नॉट गिविंग दिस. सो हियर f4 इज द स्टेट. हियर वी आर हैविंग दिस नोड एंड दिस नोड वैल्यू इज x4 एंड इट्स वैल्यू इज 7. ठीक, तो यहाँ पर जो पढ़ने वाली हैं वो नोड्स होंगी, उनके जो वेरिएबल्स हैं उनको हमने x का नाम दिया है. x4 इज 7, f4 इज 0, तो अब हमने इसको 0 नाम दिया है. ठीक, नाउ fi xi विद द हेल्प ऑफ रिलेशन. क्या था रिलेशन? fi xi इज मिनिमम ऑफ dxi xi प्लस 1 प्लस f ऑफ i प्लस 1 xi प्लस 1, वेयर i इज 1 to 3, क्योंकि हमने 3 स्टेज में डिवाइड किया है, 1 2 and 3, hence i is 1 2 and 3. So what is the procedure? Procedure is, now first we will calculate the stage 3rd, then stage 2 and then stage 1. So f3 f2 f1. f represent the stage. ठीक, स्टेज को रिप्रेजेंट कर रहा है. तो जब हम अपना i की वैल्यू 3 रखेंगे यहाँ, तो 3 रखेंगे यहाँ, तो ये आएगा f4 एंड f4 इज 0. सिमिलरली व्हेन यू पुट 2 f2, सो दिस विल बी f3, और f3 पहले ही कैलकुलेट हो चुका होगा. ठीक, सो दिस इज द प्रोसीजर. सो फर्स्ट वी विल कैलकुलेट द स्टेज नंबर 3. स्टेज नंबर 3, हियर नोड इज 7, दैट मीन्स x4 इज इक्वल टू 7. इस नोड को हम x4 से डिनोट कर रहे हैं. नाउ दिस नोड इज कनेक्टेड टू नोड 5 and 6. हियर दिस नोड इज कनेक्टेड विद दिस नोड एंड दिस नोड 5 and 6. ठीक, so what will be the value of x3 if we are denoting this as x4? So what will be the value of x3? x3 will be either 5 or 6. x3 की जो वैल्यू है, अगर इस स्टेज को मैं वेरिएबल को x3 से डिनोट करूं, क्योंकि मैं इसको x4 से डिनोट कर रहा हूं, तो x3 की क्या क्या वैल्यू हो सकती है, या तो 5 या 6. सो x3 इज इक्वल टू 5 और 6 with exactly one root each. The following table summarize the stage 3 computation. So what is x3? x3 may be 5 or 6. So 5 or 6. Then what will be the output or return function? Return function is this: d x3 to x4. Here this x3 to x4, x3 to x4 plus f4 x4. यहाँ से यहाँ ये we are writing this part actually. d x3 i की वैल्यू 3, बिकॉज वी आर कैलकुलेटिंग f3. पहले हम f3 कैलकुलेट कर रहे हैं, तो i की वैल्यू 3 रखेंगे यहाँ, तो क्या आएगा d x3 x4 दिस प्लस F4 X4 ठीक। देन जो भी रिजल्ट आएगा वो ऑप्टिमम सॉल्यूशन हमें कैलकुलेट कराना है, ठीक है। ओके, व्हाट इज X4? दिस इज X3, दिस इज X4, X4 इज 7, सो दैट्स व्हाई X4 इज 7। यहाँ दो वैल्यू की दो वेरिएबल चाहिए आपको, X3 और X4। X3 आपने रखा है 5 और 6, तो X4 कितना है 7, ठीक। तो अब ये दोनों वैल्यू पेयर वाइज रखेंगे। फर्स्ट पेयर 5 and 7, when X3 is 5, X4 is 7, that means we are taking this path. What will be the result? Result is 9. This 9. This 9 is basically from here, 9 plus 0. This value is the distance is 9 and F4 X4 is 0. So 9 plus 0, 9 plus 0 is 9, ठीक। तो हमने 9 लिख दिया डायरेक्ट। सेकेंड 6 to 7, ये 6 हो और ये 7 हो, तब इसकी वैल्यू कैलकुलेट करेंगे, कितना होगा, यहाँ से 6 और ये 0 है, तो 6 plus 0, 6 plus 0 which is, so now select the minimum one, मिनिमम को सेलेक्ट करेंगे हम, ठीक। तो मिनिमम जो भी आएगा वो F3 X3। तो अब देखते हैं, यहाँ केवल सिंगल ऑप्शन है, देयर इज नो पैरेलल ऑप्शंस, कोई भी और ऑप्शन नहीं है, तो 9 इज द सॉल्यूशन। सिमिलरली हियर सिंगल है तो 6 इज द सॉल्यूशन, ठीक। मिनिमम इज टेकन हियर, 9 है तो 9, 6 है तो 6। नाउ दिस 9 कहाँ से आया है, ये 9 आया है यहाँ से, और ये आया है 9 x इक्वल टू 4 के लिए, दैट्स वाई 7, दिस 7 इज 7। Similarly, this 6 came from here and this 6 is associated with X4 is equal to 7 and hence this 7, and this is the optimum value of X4 star, ठीक। क्योंकि सिंगल कॉलम था इसलिए एज इट इज सेम वैल्यू आ गई 7 and 7। और ये आपको समझ में आएगा कैसे आया नेक्स्ट वाले से, यहाँ क्योंकि यहाँ दो कॉलम है हमारे पास, ठीक। नाउ स्टेज नंबर 2, गिवन F3 X3। अब आपके पास F3 X3 आ चुका है, अब आपको F2 X2 कैलकुलेट कराना है। F2 X2, दिस F2 X2, फिर कंस्ट्रक्ट करो टेबल। व्हाट इज द वैल्यूज ऑफ X2 फ्रॉम हियर, दिस इज X4, दिस इज X3, दिस इज X2। X2 मीन्स 2, 3 and 4, so 2, 3 and 4। नाउ कैलकुलेट D X2 X3 अकॉर्डिंग टू दिस, पुट I is equal to 2 here, so D X2 X3 plus F3 X3, but here X3 is 5 and 6, that's why we have two columns, X3 is equal to 5, X3 is equal to 6। जैसे यहाँ था X3 is equal to 5 and 6, so they are now columns। So now if you are taking X2 is 2, X2 is 2 and X3 is 5, so from here you will see X2 is 2 and X3 is 5, that means this path you are taking, actually this path। तो हमारे पास क्या है X3 यहाँ, अब आप देख सकते हैं ये है 5 के लिए हमारे पास when you have selected 5 the minimum distance is 9, तो ये 9 आया था आपके पास F3 X3 9 when your X3 is 5, this distance is 9। So since in this column you will see X3 is 5, so X3 is 5 के लिए 9 है वैल्यू, so that's why 9, 9 and 9, यहाँ भी 9, यहाँ भी 9, यहाँ भी 9, because X3 is 5 और 5 के लिए जो हमारे पास वैल्यू है F3 X3 की वो 9 है, so 9 यहाँ वैल्यू पुट करेंगे यहाँ, so 9, 9 and 9, ठीक। अब हमें चाहिए D2 X2 X3, D2 X2 X3। तो जब 2 ये है और 5 ये है, 2 ये है 5 ये है, तो डिस्टेंस है 12, सो दिस इज रिटन हियर। जब ये 3 है और ये 5 है, 3 और 5, द डिस्टेंस इज 8, हैंस 8। व्हेन दिस इज 4, दिस इज 5, 4 and 5, डिस्टेंस इज 7, सो दिस डिस्टेंस इज 7। नाउ टेक देयर सम, दैट मीन्स अकॉर्डिंग टू दिस दोनों को सम करो। ये वैल्यू है D2 X2 और सेकेंड वैल्यू है F3 X3। ये मैंने आपको बताया कि 9, 9, 9 क्यों लिया है, क्योंकि x3 इक्वल टू 5, ये भी 5 है, तो 5 के लिए जो वैल्यू आती थी f3 x3 की वो 9 है, तो ये 9 9 9 रहेगा, ये वैल्यू 9 रहेगी कांस्टेंट, सो 9 9 9, ठीक। सो नाउ टेक देयर सम 21, टेक देयर सम 17, टेक देयर सम 16, ठीक। सिमिलरली व्हेन योर x3 की वैल्यू अब 6 हो जाती है, यानी ये 6, तो अब आप देख सकते हैं f3 x3 की वैल्यू अब 6 है, तो अब ये हो जाएगा 6 6, और क्योंकि आप देख सकते हैं बिटवीन 2 एंड 6 देयर इज नो पाथ, सो डैश, बिटवीन 2 and 6 there is no path, hence dash, simply dash. Otherwise here we have 6 and 6, just like 9 9 9, here we have 6 and 6 because we have 6, x3 is 6, for f3 x3 will be 6 and hence 6 and 6. Now find out the distance between 3 and 6. 3 and 6, the distance is 3 and 6, 3 and 6 the distance is 9, so 9. 4 and 6, 4 and 6 the distance is 13 and hence 13, so their sum is 15, their sum is 19. Now we in this row here we have 21, here is dash, so what will be the minimum of these two, because we have to compute the minimum, so in this row we have only one value 21, so that's why I write down 21. Here 17, here 15, take the minimum, we have 15, because we have minimum, we have to find out the minimum, so 15. Here 16, here 19, what is the minimum, 16. Now this 16 is associated with this, ये 16 कहाँ से आया है, यहाँ से आया है, इसके लिए x3 की वैल्यू क्या है 5, तो x3 स्टार की वैल्यू यहाँ हो गई 5. ये 15 कहाँ से आया है, ये यहाँ से आया है, दिस 15 ये यहाँ से आया है, यहाँ x3 की वैल्यू क्या है 6, hence 6. ये 21 कहाँ से आया था, यहाँ से, here x3 is 5, so 5, so that's why x3 star is 5 6 and 5, corresponding to x2 is equal to 2 3 and 4. तो दो स्टेजेस हमने सॉल्व कर ली, ये और ये. नाउ वी आर गोइंग टू सॉल्व स्टेज नंबर 1. सो नाउ स्टेज नंबर 1, सो स्टेज नंबर 1, अब हमारे पास f2 x2 आ चुका है, f2 x2. नाउ फाइंड f1 x1. सो अगेन कंस्ट्रक्ट द टेबल. Here we have x1 is equal to only one option 1, so that's why 1, but for x2 we have three options 1 2 and 3, and hence we have x2 equal to 2, x2 is equal to 3, x2 is equal to 4. Then again find out this d of x1 x2 plus f2 x2 according to this formula. Put I is equal to 1 here, put I is equal to 1 here, so we get this d1 x2. अब हमारे पास x1 की वैल्यू 1 है फिक्स, बट x2 की वैल्यू 2 हो सकती है, 3 हो सकती है, 4 हो सकती है, ठीक. सो नाउ if you are selecting 2, then for 2 minimum value is 21, hence 21. If you are selecting minimum is 21, so 21, and the distance between x1 and x2 is the distance is 7, so 7 plus 21 is 28. If you are selecting x2 is equal to 3, the minimum is 15, so 15, and the distance between 1 and 3 is 8, so 8 plus 15 is 23. If you are selecting x2 is equal to 4, then here the minimum is for 4, minimum is 16, so 16, and from 1 to 4 distance is 5, so 5, take their sum is 21. Among these three options 1 2 and 3, minimum is 21, so write down here, so this is your f1 x1, and this 21 came from here, and for this x2 is 4, hence x2 star is 4. Star represents the optimum value, ठीक, is 4. तो अब हमें ये हमारा टेबल बन गया है. अब हमें क्या करना है, बैक ट्रेसिंग. सो नाउ कंस्ट्रक्ट द बैक ट्रेसिंग. सो दिस 21, सो हम स्टार्ट करेंगे यहाँ से, तो सॉल्यूशन निकालने, एक से ज़्यादा सॉल्यूशन भी हो सकते हैं, तो हम इसको क्या करेंगे 21, लास्ट आया है सॉल्यूशन 21, तो इसको हमने ट्रायंगल बनाया, ट्रायंगल. अब ये कहाँ से आया है 21, ये यहाँ से आया है 21, सो अगेन ट्रायंगल. अब इस 21 के लिए हमने क्या क्या किया होगा, 5 plus 16, सो ये लास्ट क्वांटिटी दैट मीन्स दिस F2x2, दिस इज F2x2, इसको हमने ट्रायंगल से बनाया, क्योंकि ट्रायंगल वी आर रिप्रेजेंटिंग दिस सॉल्यूशन बाय ट्रायंगल। जो भी यहाँ से सॉल्यूशन बनता जाएगा उसको हम ट्रायंगल से रिप्रेजेंट करेंगे। एक से ज़्यादा हो जाएंगे तो ट्रायंगल, स्क्वायर और भी कुछ यूज़ कर सकते हैं। सो हियर वी आर यूजिंग ट्रायंगल। सो ट्रायंगल, ये 21 कहाँ से आया, यहाँ से, और इस 21 के लिए 16 का यूज़ हुआ होगा। सो ट्रायंगल। अब इससे पिछले वाली टेबल में देखेंगे हम 16 कहाँ है, 16 आया है यहाँ से। सो दिस इज ट्रायंगल। अब ये 16 ढूंढो कहाँ से आया था, ये 16 यहाँ 19 है, यहाँ से 16 ये यहाँ से आया। सो इसको भी ट्रायंगल बनाओ। इस 16 के लिए हमने इस 9 का यूज़ किया होगा। अब इस 9 से पिछली टेबल में जाओ, ये 9 कहाँ से आया था, ये 9 आया था यहाँ से, ट्रायंगल। तो इसको भी ट्रायंगल बनाओ। इस 9 के लिए हमें कहाँ से जाना पड़ा होगा, यहाँ पे, तो अगेन ट्रायंगल। सो अगर इफ यू विल सी द सॉल्यूशन इज व्हाट, इफ यू जस्ट यूज 1 to 4, 1 to this 4, fine, and now here is the triangle, so 1 to 4, 4 to this 5, क्योंकि ये ट्रायंगल है इसका मतलब ये ऑप्टिमम है। फिर ये 9 था तो इसलिए इसके कॉरस्पॉन्डिंग x4 इस ऑप्टिमम है। सो आप देख सकते हैं 1 to 4, 4 to 5 एंड 5 to 7, दिस इज द सॉल्यूशन। तो दिस इज द 1 to 4, 4 to 5, 5 to 7, and solution total distance is 21. So this is the way we can solve the problem. Find discrete problem. In the next class we will discuss about the continuous problem. Continuous problem को discuss करेंगे, ठीक? So okay, thank you.